I'm streaming. Hello, people. Let's take a look at this. And so we're on the back side, and we did okay on the front. Did it make sense? Okay. And this was the second page, and we did okay on this page. Made sense? And then we were on this page, correct? And was I doing, and I hadn't started example 6, is that correct? All right, so this is a very, very, very common question, is that the question will read, the rate of change of y is proportional to y, okay, that type of thing. So the rate of change of y is always going to be this form, dy dt. It's a derivative with respect to time. And then proportional means you have some constant times time. Now, why do I know that this is my variable? Because it's dt. dt, when I say respect to time, time is my input value. Y is my output value. Is that making sense? This represents some number. So I don't know if you guys, did they talk about direct proportions in pre-calc? Did they or not? You don't remember, okay? This is a direct proportion. It's a very simple linear equation that goes through the origin. This is the slope, but it's also the this is the slope. This is also the constant of proportionality. That means if I had this. Hi, how are you? Are you done?
Yeah.
You want to hand it to me?
Sure.
All right. Yeah, where are we going?
Foy.
Foy. Which Foy?
English.
Mrs. Foy.
Mrs. Foy, yeah.
I don't know if she'll even look at that pass, but I'm enjoying writing it right now.
All right.
Because I wrote a lot of stuff on there about you.
Thank you.
The eldest. I didn't know there was a younger.
Yep.
All right, so if you take a look at this, what does this mean? It means y is 3 times bigger than whatever my x value is, correct? So if I have something that's 2, y is going to be 6. That means there's a proportion between them. That means if I take y and divide it by x, I'm going to get 3. That's the proportion. 6 to 2. 9 to 3. 12 to 4. Correct? All of those would be solutions for that constant of proportionality. Here's another one. Y equals 1/2 x. That means y is going to be half of whatever x is. So if this is 4, this is 2. If this is 10, this is 5. If this is 120, this is 60. So if I had y over x, I'd get a half, correct? And even this, it means my proportion is 1 to 1, right? They're equal. So that slope is always the proportion between x and y. I don't know if they ever had that explained to you, but that's what that means. But in calculus, in this particular problem, hi, how are you doing? Hannah's out there. You'll see her, she's at one of the tables. I think she's over there in that direction. Do you see her?
Thanks.
Okay. And then Andrew, you got mail. And I made a mistake on here. This should be y. And I wrote t because it's proportional to y. I am sorry about that. Okay, that's my mistake. And it has to be y. Because now I'm going to find the general solution to this. Okay, I'm going to find the general solution. Well, what does that mean? That means I'm going to have y dy equals k dt. And I leave the constant on this side because I want to try to get y totally by itself. If it was y plus 3, well, then I'd have to bring the y plus 3 over there. But since it's k times y, I can simply divide by y, and I'm really messing up. It's really 1 over y. Sorry about that. I bet you Cora asked, why didn't he write 1 over y? Cora, I didn't hear that because my batteries are dead in I don't have my machines on. Okay? All right, sorry about that. So I'm going to figure out the antiderivative to this first. Remember, this is a number. The only two variables I have are t and y. So read, what's the antiderivative? What would be the antiderivative of 3? You'd say, that's the derivative. Well, in this case, 3t, right? Yeah, you would say 3x, it was dx. I kind of threw a curveball at you. It's going to be 3t, right? And if it was 5, it'd be 5t. Well, since it's k, it's going to be kt plus c. And over here, Maya, the antiderivative of 1 over y, that's why it was important that I wrote 1 over y, Cora, I screwed up, is going to be what? Yeah, we're starting to feel comfortable with that now, right? And that means y is equal to e to the kt plus c power, right? Well, e to the c is going to be some constant that I called b. And if you notice, b and c can be the same. Are you guys okay with that? It's just some number that I'm multiplying e to that power. And this is the classic model of an exponential equation. Exponential growth, exponential decay. Exponential growth, exponential decay. And I think you guys saw this last year. Am I right in FST? Yes or no? Ryan is saying nodding affirmative. Morgan, I think, is. Okay, a few of you are. All right? And so that's where that comes from. That comes from a rate of change proportional to y every single time, because if I divide correctly by y, Cora, I get 1 over y. That leads us to the natural log, which leads to this exponential form. And I just want you to see that c and b are the same value. It is called the initial value. Think about it. When t equals 0, and I have k times 0, that's going to be 0. E to the 0 will be 1, right? This is my initial value. So if I have growth, that's what at time 0, that's the value of the growth. It's not so weird. Not everything starts at 0. On my birthday, which is April 3rd, my mother used to call me up every day on my birthday. She did that for 60 years, McKenna. And she sang happy birthday to me. And then she'd go through this litany of what it was like when I was born, how big my hands were. How big were they? Exactly that size. Can you imagine a baby with that size hands? They have not gotten any bigger since then. And I weighed 8 pounds, 15 ounces. I was huge. And my mom is little. Right after that, she had a pair of twins that each weighed 6.5 pounds. Big twins. But I was the biggest of the family. And then she'd tell me what my length was. Okay? And so on the day that I was born, C would have been 8 pounds, 15 ounces. Does that make sense? Hopefully I did not grow exponentially during that time. That would be bad. All right. So K is the proportional constant. It alters the rate of growth or decay. Okay? If K is greater than 0, we get growth. In other words, if K is positive, things are growing. If K's are negative, things are decaying. And typically in our culture, Andy, growth is looked as positive and decay is looked at negatively. Okay, that's kind of how I remember that. All right. T is time, and Y is your amount of material after a period of time. And you'll get questions like this. So, I love this. This was a quote by Groucho Marx. It's in one of the airports in London. I think it's at Heathrow Airport. Time flies like an arrow, fruit flies like a banana. And because of that, we always wash our bananas, so we have no fruit flies in the summertime. You know they lay eggs. Why does Colburn spray water on their vegetables? You ever notice that? Because fruit flies lay eggs on the skins. And who has a microscope at home to see all those eggs on their fruit? No one does. Right? It's gross, isn't it? Right? But they're there. So, we have 50 flies at the start. After 2 days, we have 150 flies. I'm telling you that we have exponential growth. C is 50. Why? McKenna. Because it starts at 50? Is that what you said? Okay. Because that's our initial value. So I have this. We need to figure out K. Well, we're going to figure out K because I know this other bit of information right here. I know that I have 150 flies. Here's 50. E to the K times, and I know after 2 days. So now we have an equation in which we have to solve for K. Nick, what's the first thing I'm going to do? Right, and I'm going to get 3 is equal to the E. Are you okay that I write 2K instead of K2? Okay. What's the next thing I'm going to do?
Take the natural log.
Yeah, so I got the natural log of 3. Can you see that I'm going to divide it by 2, and that's going to equal to K? Are you okay with that?
Yeah.
Because I get the natural log of E, which is 1, and I'm left with 2K. Are you all right with that?
Yeah.
So I skip some steps, and I don't have a calculator. You do, Sawyer. Take the natural log of 3. And then divide it by 2. What do we get? Point something, I bet. 0.5492, is that what you said? 3? I don't know where 2 came from. That's my K. Since it's positive, Andy, I'm going to have growth. So now my equation is Y equals 50, because I got to have more than 50. 0.5493 times 5, because 5 days. So how many flies do I have? Make sure on your calculator put that in parentheses. It's a big mistake that people make. Jeremiah, did you get an answer?
Yeah, 779.3989.
Yeah, I don't know what that looks like as a fruit fly. Probably one I tried to, maybe squished or something like that, right? Flies. Probably 179, 180 flies. A baby fly. I don't know. Deformed fly. That's a lot of flies. You know how you get rid of them then? You get a little dish and you put soap in it with sugar water. Am I right, Maya? You've done this before, right? Because they like sugar water, but the film of the soapiness doesn't allow, and they drown in there.
Put like saran wrap over it and like.
Oh yeah, with holes, and they can't get up. Yeah, that's the other thing. They can't get out, and so you kill them. Well, if you wash your fruit, they don't get there, okay? Because it's gross. All right, especially when you know that the fruit you're eating has eggs all over it. It just even makes it thicker. So we got plutonium, plutonium-239, known as nuclear waste, that we're storing in Nevada, because obviously we have no life in Nevada. You know where else they were thinking about storing plutonium at one time? Someplace that has a whole bunch of granite, because granite's almost impenetrable. And obviously there's no life in Stearns County. Look how they drive. They don't care about life. They don't care about red lights. They don't merge onto merging. They yield. They don't care that they're going to get rear-ended. Right? You've been there. Highway 15. Just that's all I need to say. Highway 10. Parked in the middle of the road. Alrighty. So, what is 500? It's got to be what? Sawyer. What's it got to be? This year we have 500 pounds of plutonium, and we dumped it in the Nevada desert. We just put it there. That's got to be C. The half-life. Do you know what it means for a half-life? Have you ever heard of a half-life? What does it mean to you?
So after that period of time, it's half
Yeah. After 24,360 years go by, I'll still be teaching. Well, I'll be in here, but I'll be petrified. I'll be in that corner, with all my other stuff. Okay? I'll probably be small, like a wizened doll, and I'll probably be on a shelf. Okay? We'll have 250 pounds of plutonium, correct? And then how long will it take there so there's only 1 pound left? Forever is my answer. Well, the first thing we're going to do is figure out K, correct? So I have 500 E K times what, Morgan? Time, right? What is that time? What's that going to equal? Give you a hint? $250. And like Nick said, you would divide by 500, correct? And I get 0.5. Could I have gone here to 0.5 right away and say that's going to be a half? And been just here, E equals 24,360 K. So my answer is going to be the natural log of 0.5 divided by 24,360. That's what K is going to be. That's going to be a itty-bitty number. What is that number? Did you get one, Tegan? Because, that was going to be my question for you.
Negative
-0.0000285. That's what K is. It should be negative because we want it to decay. It should be a really small number because it takes so long to get rid of it. So, we have Y equals, we started with 500, E to the negative 0.0000285. 0.0000285t. Would you agree, Cora?
Yeah.
Okay, now we want to know how long, so we want time, right? How long it will take to get 1 pound. So what am I going to put that 1?
Before y.
Y. So I got 1 equals 500 e to the negative 0.0000285t. So it's going to be the natural log of 1 divided by 500 over a negative 0.0000285. That's going to equal my t. And it should be a long time. It should be more than 24,360 years, right? Because that'll only bring us down to 250. Another 24,360 will bring us down to 125. Another 24,360 will bring us down to 62 and a half pounds, right? So how many years do we get? What is it? 218,056 years. So 7 years, right? Because that bleeds us into the 7th year. You done those kind of problems before? I made a mistake. You got a question?
Never mind.
You sure?
Yeah.
Okay. Is it my handwriting that's lousy? That's a 7. Yeah. Nick agrees. He understands. That bothers my wife. But she still loves me. It's amazing with all my faults. All right, is there a backside? All right. This time we only got radium. On the test, I got rosarium. It was created by a dog. I think it's a funny question. A sample containing 1 gram of radium, which has a half-life of 1,620 years. How much radium will remain after 1,000 years? So set it up for me, Jeremiah. I'll give you a hint. Y equals. You want me to give you the whole thing first?
That'd be kind of nice.
C e to the kt. Do I have an initial value?
Yes, 1.
Okay. Y equals 1 e to the k. Do I have time?
Yes, 16, 20.
1620. And then what is y after 1620?
0.5.
So I could write 0.5 equals e to the 1620k. Are you okay with that notation?
Yeah.
Can you see it okay?
Yeah.
All right, so somebody with a machine is going to do what?
ln 0.5 over 1620.
And that's only giving me my rate of growth, correct?
Yeah.
Alrighty. And then I'm assuming it's, oh, excuse me, yeah, it's going to be rate of decay because it's negative, right? And what is that going to be? Do you have that, Jeremiah? I think Jeremiah's got a machine too.
Yeah, it's negative 0.0, it's 3 zeros and then 427. 428. If you round up.
Maya's at 8 okay? See, 7's and I'm okay at making 7s, 8s. Making 7s out of other numbers are hard. So we have y equals 1, I don't have to write, e to the negative 0.000428, and this time I have time, don't I, Jeremiah?
Yeah.
So I'm going to put 1,000 in here. I know I better have less than 1. But my guess is I have more than 0.5, wouldn't you? Because I haven't gone my 1,600 years, right? Is that making sense? I kind of think ahead of time so I don't write down numbers. One time, I'm admitting this to the abyss, I had a student that wrote down as an answer, low battery. And I asked him why, it was a him, and he said, because that's what my calculator told me. Which indicated a lot of problems. That meant he had a personal relationship with this machine. Okay. So what does y equal?
0.652.
So, grams. So it kind of makes sense with what we were talking about, right? Okay?
Yeah.
Alrighty. Now, Ryan, we changed it up a little bit. An initial investment of $6,000 if compounded continuously. If you remember, it's this, y equals PE to the RT, correct?
Yeah.
It's the same thing. Look at this. CE to the KT. What do? We're just dumb as math teachers. We change the letters, but it's the same thing. But my initial value, my initial investment, my rate of growth or decay, my rate of growth, why? Why would you want a rate of decay if you're investing money? Correct? But doesn't it look the same? We should have just stayed with this. But the business people would have issues because it's principle. I don't care what they think. It's C, my initial value. C is always a better letter of the alphabet than P. And oh my God, K is a heck of a lot better than R. CK. Do you see that? All I need in here is a V somewhere. It'd be perfect. But V rhymes with E. That's how I think. So let's go over here. Fill this out for me, Ryan. Y equals 6,000. E.
Yep.
Initial investment continuously will be this after this many years.
Yeah, so
Y will have to be what?
80.
$8,950.95.
Yep, that's equal to 6,000 E 10 times
10 times T. Like that?
Not K.
Oh, K. K times 10.
Yeah.
Okay? So what are you going to do first? Or somebody with a machine?
So you want to take the natural log of both sides. So
Not yet.
yeah. Natural log of
I,
6,959%.
yeah, I got to divide by this. Is that what you're
Oh,
saying?
yeah, I got to.
Okay.
Forgot about that.
Yeah, it's the biggie. We got to do that division. And then take the natural log to get this down, right? And I'll have 10K. So I'm going to divide by 10. Are you okay that I make that many jumps? And what does that give me?
0.04.
Ooh, 4%. Actually, it's equal to R. R equals 0.04, 4%. My guess it was 0.039999999999.
No, it's 0.0400000000.
Okay, so it's 4%. Okay. I made this one up, so I knew it was something like that. All right, so now we're back. It says, so we got this. We know our equation is y equals initial value of 6,000 times e to the 0.04 t. Correct? And we want to double it. Right? Now, did I ever talk about the rule of 72? Okay, and I heard some guy gave you guys a lecture last year in pre-calc. He comes in and says, this is a bogus thing, okay? But this is what I do, okay? I take 72, divide by 4, get 18. So I just use it as a check. It's not perfect, but I should get an answer around 18. You understand? If I get an answer like 25, I made a mistake. If I get an answer of 2, I made a mistake. You understand what I mean? I'm thinking it's going to be around 18. So what am I going to put here?
12,000.
12,000. And I could have skipped this part, and I could have said this, 2 equals e to the 0.04 t. What's my next step that you're going to tell Tegan to do, Ryan?
Natural log of 2 divided by 0.04.
And what do we get?
17.329.
So in the 18th year, right, the 18th year, I'd get double my money for sure, plus some change, correct? So 18 is not perfect, but it gives me a good estimate. That would be my argument. It leads you into a direction. Now, further and further, you know, like if I had 0.5%, that means I'd have to go 144 years. It's going to get a wider gap because this is a natural log function, or it's an exponential function. It's not a straight line. Does that make sense with everybody? Okay. But the closer they are together, the better the estimate. Let's turn to the next page. Is there a next page? No, that's it. All right.